collections today. And this is not, like the finance department where the credit card company calls you and say, do you got the money? When are you going to send the money? Not that type of collections. We're talking about a framework in Java for organizing your data. But before we do that, I want to touch base real quick on something called an enhanced for loop. Have you guys used the enhanced for loop yet? Got one person. So the enhanced for loop is basically a for loop, and the iterator of the for loop is the first declaration. So the iterator could be declared by the variable type. So you would say, for example, if your collection was of type string, you would say string, something indicative of what the collection would contain. So if it was a collection of names, you would use the singular form of the collection. So names, the iterator would be name. So string name colon, and then the collection object, right? And just by using that, it will automatically loop through that collection. Now here's the thing, with the for each loop, this is what it's called, you have no ability at all whatsoever to do any modification of the loop. Can't do any modification of the data in that array or that collection. You can use it just to quickly iterate through that loop in a sequential fashion. Okay? So here's an example. Again, the collection here is called names, and this is the best practice. Call your collection something that ends with an S to signify it's more than one. It's plural. And then in this instance, I have the list interface declaring a generic of string with a name called names. And it equals a new array list. Array list implements the list interface. So that's how that's able to work. Then down below in my for loop, I have, again, declaring it out, string, the singular of that name. Now, that's not a requirement. You could call the iterator anything you want to call it. You could call it supercalifragilistic whatever, right? But the best practice is to use the singular form of whatever the collection is, okay? And then you just iterate through it, and it auto-magically, in the system out print line, it grabs that string and it spits it out. Okay, it's a very easy usage for reading from a collection. But remember, you cannot int it for updating the collection. If you want to update the collection, you have to use the old-fashioned for int I equals 0, I less than some number I plus plus, right? That's how you'd have to do it that way. Okay. Again, improved readability, the reasons why you would use it. You can see from the example on the left, this is the old way of doing it, to the example on the right. And you notice in this example, both of these, the one on the right is suggesting that in is a collection of ints, if you look at it, right? In the previous example, name is a collection of strings. Here it's I is the int, and in therefore would have to be a collection of ints. Okay? All right, so let's talk about collections. Collections in Java. This is a framework that provides you about 10 different groups of objects, of classes that you can use to iterate through objects for manipulating different types of objects. Java collections, it can achieve, as I've got highlighted in bold here, all of the things you need to do of searching, sorting, insertion, manipulation, and deletion of objects from that array. Now, just a quick refresher, when we're thinking about an old-fashioned array, which is not part of Java collections, right? So if I have something like this, right? This is not part of collections. This is the old-fashioned way of doing it. But I'm highlighting this because remember, every time that you declare a variable, you're taking up physical space on RAM. And it's important that if I declared, say, something like this, string name, this is going to take up a specified, it's going to hold a specified amount of RAM, register on your RAM. And it's going to be designed to only work with things of type string. When I do this, I'm specifying that I'm going to have 1, 2, 3, 4, 5. How many other variables are declared? Or if I do it like this, right? New string. Then I'm saying I'm going to hold 5 variable places in sequence, back to back in your memory in RAM, okay? Now, when we jump forward to think about an array list is basically it's a methodology for wrapping up an array like that, okay? It gives you all of these methods that allow you to make what you see over there, that string, square brackets, names, into a class object, okay? So this is the important part of collections. So before I touch base on that anymore, I want you to tuck that away in your memory, how that variables are stored in memory, okay? Don't forget about it because it's very important in a moment. But these, we'll come back to it, but these right here are the different types of collections. Everything in blue is an interface. Everything in green is either it's an abstract class or it is a fully implemented class, okay? So we can see that we have a hierarchy of all of these different types of collection objects. So we have iterable at the very top, and you can go to Oracle's website and look up the Java doc on an iterable, and it'll tell you all of the specifications, the methods for the iterable. And it's important to understand that because as these all extend and implement in some shape or fashion from iterable, it means that the methods that it specifies in iterable are going to be available in all of these other interfaces or classes, right? This is the hierarchy. This is the object-oriented nature of Java. So we're going to be concerned primarily today. We're going to start off with the list, the array list, and the linked list. I'm not really going to talk about vector or stack today. They're not used as much, but they still have some purposes. But 90% of your work is going to be done with either array list or linked list. Okay? So we're thinking about the list interface. Okay, the list interface. And I mentioned there is a URL here. This is from Java version 11, JDK 11. We're at 21 right now with 22, I guess, is the most recent. This implementation of the list has not changed. So you can go out to this site, this Java doc, and you can click on it, and you're going to get information on the list. And it is weirdly, oh, it's because of that. There we go. Do it like this would be better. All right, so this is the list, right? You can see it's of type generic, meaning it'll take some type, some object type. Quick question, this is a quiz for you. What can it take? Can it take primitives? No. cannot take primitives, right? Because it has to extend from object, and primitives don't extend from object. So anything that extends from object can go inside the list. You specify that the list will be of type string, or the list will be of type integer, like the wrapper class. You could specify that it will be of a type of custom class that you create. There's all different types of implementations. So here you see that the super interface for it is collection, and it's iterable, and you can see again it's using that generics. And then we have all of the known implemented classes of list, right? Let's go on down here. You got a nice description. I'm not going to read that for you. Here we go. And these are the methods. Now, these methods are going to be important to kind of recognize and know, because they're used by both array list and linked list. So we have add, and you're going to specify the index that you're going to add it, as well as the element. Or you could use the non-overloaded method, which just adds the object itself. When you add an object to a list, by default, if you don't specify the location where you're going to put it at, it puts that object at the end of the list. So if you're thinking about a old-fashioned array over there, how would I do that with an old-fashioned array? If I specify 5 elements and I'm going to add a 6th element, how do I do that? I basically have to create a brand new array, don't I? I create a brand new array in memory. I copy the objects from the old array, put it in the new array, and then I add the next element. All right? An array list, which we're going to talk about in a moment, basically says, hey, we're going to set the default underlying array type that you see over there. We're going to set it to an initial amount. And I think the initial amount's like 100. Okay? And what happens is, as you add elements all the way up and it gets closer to 100, it says, oh, we'll reach the max, and it automatically in the background swaps it out, creates another array that's now 200, and it adds all of the previous elements from that array to the original, to the new array with the next element. And then it allows you to continue to add again, right? All of this happens behind the scenes. So you have to think about that. That's, if you know that your array will grow, I would not want to have to write the code to do all that type of creating a brand new array in the background, and right? I wouldn't want to do that. That's why we'd want to use collections. And that's the primary purpose of collections. Collections solves that issue for developers. So it's very powerful. All right, let's go back here to our PowerPoint slide. Okay, so this is the list container. Please make sure you look at that Java doc for the list. And let's talk about an array list. Okay, so we have array list. We can see that it implements the list interface, and interfaces extend from other interfaces. Okay? Java 101. You cannot extend from an interface if you are not an interface. You can only extend from like types. So a class can only extend from a class. If it is an interface, then you have to implement that interface, meaning you have to now create all of the methods specified in that interface. You have to implement them. All right? So an array list is a Java class implementing the list interface. It implements all of those methods. It does all of that work I just talked about with an array behind the scenes. It's very powerful. All right, let's talk about memory storage. How does it work? It works exactly like I pointed out a minute ago with the array. We have a specified list of designated area in memory, and it's adding it sequentially on the RAM physically, one after the other behind each other. Now let's do a little thought experiment. Let's say our array is 10,000 elements long. And I need to add to this array, let's say it's an array of names, and I need to add to this array of names somebody with the letter, begins with the letter M. M is roughly in the middle of the alphabet, right? What's going to happen if I try to add it at the designated reference spot in the middle of that container, that object that's 10,000 elements long? What happens in memory? Yeah, but think about what happens. It isn't, if it's physically specifying one register after another in sequential memory on your RAM physically, if I try to put something right in the middle, what happens to that, all the elements that are after? It has to be shifted. Now that is memory intensive. 10,000 elements, and now I'm going to have to shift 5,000, so it goes, okay, well, we gotta shift you guys. Ready? And this person shifts, and then that person has to shift, and then that it literally has to do it one at a time. So you have to think about how you're going to use an array list. Is the purpose of your array list to try to put things all the way back at the beginning? Because if it is, and that array list is already 1,000 elements long, you've already increased the processing time for your program to run, right? These are one of the classic issues that we face with an array list. If you're only going to add it to the end, no problem. Easy peasy, right? Easy peasy, lemon squeezy. It's not an issue. But if I have to insert it in there anywhere in the middle or the beginning, then it's going to create issues. So this is where we come to the next different type of list implementation, and this is called a linked list. Now, a linked list is what we see here. It's an ADT, it's an abstract data type. Again, it implements the same list methods. Add, get, right? All of those. But it also adds set. We're going to set something at a particular point in memory. How might we construct, do a thought experiment with me here, how might we construct a type of collection that lets us get around the old-fashioned array? I already see some smoke coming out of your all's ears. You're not sure about this one yet. Think about how we might do that. If I know that when I create an object, I'm taking up a particular point in memory, what if I could have two variables in that object that are references that say that the next object is going to be this other object that's created? Now when the object is created in memory, it has a reference to where the next object is located. So if you look around the room, right, and we're thinking sequentially, sequentially would be I have to pick up this computer with an old-fashioned array list, shift it down, the next one has to be shifted down, the next one has to be shifted down, right? That's an old-fashioned array. But with a linked list, let's imagine it's different. That this has a reference to number 6, and number 6 has a reference to 21, and 21 has a reference over here. Now think about how easy it is to insert something in between. All you're changing is the link. you change the reference point. You say, well, I'm no longer going to reference 21. I'm going to reference this new object, which now references 21. And it doesn't care where it lives in memory because it could be scattered all throughout the RAM. Is anyone understanding? Is the light clicking on? It's flickering. Right? Okay. Think about it like that. Okay, so you got your RAM. And item 1, I create the object. It's of type, let's say it's of type person. It's a person class that I created. And it exists right there in that physical area of RAM. And I create the next item in my collection. As soon as I go to add it, it says, well, who was my previous? It says, oh, it was item 1. So item 2 now gets created over there in RAM. Doesn't matter where we put it, but as long as the link is valid. Right? And then I just keep adding items. Doesn't matter where they're at as long as the link is valid. So they've got two different types. Before Java created the linked list, you'd have to create your own linked list. And it's really not a difficult process to do. You can actually create a linked list by creating a class that has a reference to itself. That's it. This class has a reference to itself and a follow-on reference. So you could have a single linked list or a double linked list. Right? All right. So the power of this is, if you have 10,000 elements now, it's not a problem. There's no memory consumption at all because all I'm doing is just inserting a new item, saying, hey, make your reference go there, make your reference go there. And all it is like, it's just a link. It's just a reference. There's no actually shifting of the objects or shifting all of the objects in memory. Okay? Some of you are still looking at me like you don't get it, but okay. We're going to go on. All right. Well, let me pause. Tell me what you don't get so we can address it, because this is important. What doesn't make sense to you? It's okay. Anyone. Tell me what doesn't make sense so we can kind of walk through it. Because if it doesn't make sense to you, someone else is probably thinking, yeah, it doesn't make sense to me either. Are you guys all ashamed? All right. If you get it, then say, I got it. So you guys are all ashamed. All right, tell me what you don't get. Come on. Bill, what don't you get? Tell me where I lost you. Seriously.
Just a very complex topic.
Okay. All right. So notionally, just to help you all with this, if you ever have to do inserts in the middle of an array, just say to yourself, linked list. That's the object that I know I want to use. That's the type of collection I'm going to use. If I have to know I'm going to be modifying elements in the middle of a list. If it doesn't matter and it's always at the end, array list. Adding new objects. Adding new objects. Okay? Notionally in memory, though, this is how it works. Okay, this is how it works for linked lists. Okay? All right, so common linked list methods. You got the get, which is you're passing in the integer of that element. So just like an array list, if it starts at 0, goes up to the count, whatever it is. And you're saying, I want element at 25, and it'll get that element. Or you have set, and you can set the element at 25 and add the object. and it replaces the element at that particular location. Now keep in mind, with a linked list, setting an object at that location replaces the object. So it's different than adding an object at that location. Okay? Then you got size and remove. Size is what you would expect. It's a method that tells you how many elements are total in the collection. Okay? So you have this thing called a list iterator, and you can use the next or the next index, the previous or the previous index. So think about in terms of a while loop. You have while, right? Parenthesis, the names. If names is a linked list or a list, you would say names.next. And if names.next is true, then it would do what's inside of the while loop. Meaning that at whatever iteration you're in that list, it's going to ask the question, is there something next in the list? Okay? And if there is, it will safely move to that next item. And yet, of course, you have previous and previous index and so forth. Okay. Has next, has previous, add an object, remove, and set an object. All things we've already kind of covered. All right. Let's talk about maps. Maps, this is now leaving, if we look back here, I don't think map is identified. Yeah, map is not identified in our collections because it's technically not a collection, right? But a map is what we would call an associative array. So if you're using JavaScript, you would have a syntax of something like this. You would have you'd say var, oh, that marker's bad. Right, var, when you're declaring a variable in JavaScript. Let's see, I'm going to call it a map because that's what we're demoing. And then you would have curly brackets, right? And then inside, you would do things by colon, and then it's separated by comma. And that would go on to the next. So in an associative array, you're associating something. Typically, you have a key and a value. So that can become kind of powerful because it means that your map in the Java world okay? You're specifying a generic for the key and for the value. So the key could be of type string, and the value could be any valid object that you decide. So a typical example that we often see with a key-value pair like this is, let's say that you've created a person class, right? And the person class, it could be a record, by the way, since you guys have records now that you can use. It could have like the name. It could have date of birth, right? Everything associated to a person. So you could have a map of person objects. And then the key is something that is unique for you to automatically get that particular object out of the map. Okay? Now the value, the power of the map is different than that of an array, because the key value You could have 10,000 values in a map, but as long as you know the key, you can immediately grab that record. In fact, your databases use this type of methodology. They call it often an index, right? Creating an index on a table. And behind the scenes, you get that you could create an index on different types of columns as long as they're unique. It's the same process for a map. The key has to be unique. You can never have duplicates of keys. If you try to enter a duplicate, you're going to override the element at that particular map, that particular iteration. Okay? All right, so here we have a map, and the implementation is a hash map. Okay? And then we have put, which put is the method that we're going to say, hey, at this location with this key, we're going to put this value. Okay? And then get is where you'd put in the key, and it would automatically get you the value from that location. Okay? All right, let's do a quick example to go over some of these in Java. Okay? With your IntelliJ open, with IntelliJ open, we're just going to create a quick project, and we're going to call it, we'll just call it our collections samples. I don't know what it just did. Oh, duh. I did a search, hang on. There it is, new project. And we'll call this collection samples. And we'll click create. And the first thing I'm going to do is I'm going to create just a quick record class. Okay? So we're going to select record. We're going to call this person. And we need string F name, string L name. We're going to use an int. Let's see. We're just going to use a string for DOB. Okay. Very simple record, right? All right, so let's go over and create a new Java class. And this is going to be, we'll just call it main, because we're going to put a bunch of different things in here. PSVM for public static void main. Okay. And let's do a person object. So first name Michael, you can put whatever you want. Last name Rogers. And date of birth. That's a big question. All right. Yes.
Is DOB mean date of birth?
Yes. Yes. All right, so I have created one simple person object. So let's do a list. And general best practice is to create the, let me back up. If you need all of the methods that a linked list will use, then you need to declare it as a type linked list, right? So if I only want an array list, I'm just going to say list, because the methods that I'm going to use are pretty much contained within the array list. But if I'm going to use a linked list, then and demonstrate those differences in the methods, then you want to actually create the variable starting with linked list instead of the interface. You guys follow me? Okay. So I'm going to create this list of type person, and make sure we do the import. Okay. And I'm going to call my list persons equals new, array list. You'll notice in this instance, I don't have to come in here on the second generic identifier and declare that it's person. I've already done it at the first one. You can. There's no harm in doing it, but it's not required. It's not necessary. All right, so I have persons. So now I'm going to say persons.add, and I'm going to add Michael. All right, so I've added to my array list Michael. I could also do it like this: persons add new person, and I'm calling the constructor in this sense, so it's very simple to add this. Let's see. Okay, so I've got a couple of different variations. Now using the for each loop, I would use the type, which is the type of object that is in that loop. So I'm going to use I'm going to say I'm going to use a person, and then I'm going to declare the collection that I'm accessing, persons. Now, if I system out print line this information, you guys know that it's pretty much just going to spit out memory locations instead of actual data. Well, for records, it actually gives you the readable part, the readable information. If I created a raw class, it would just give me memory locations. Okay? So that is one way of using the array list. The linked list, if we were to change this up and just say linked list, and over here, linked list, same methods work, because all I'm using right now are the add, which is from list, which linked list inherits. But let's say now I want to say persons add at a particular index. For example, I want to add it at index 0. So in this instance, it's going to take what was originally at index 0, which was Michael Rogers, and now it's going to replace it with a new person at that index. And we also don't know this person's date. Okay? So if I run the code again, we'll basically see that John Cassidy has been inserted to the top of the list because I've specified the index that he will live at. Okay? So these are some examples of using the list, the array list, and the linked list. Now, let's take this a step further, and let's add a map. So for a map, you can see that this is within the Java util. You need to do the import for that. Make sure you have the import for map at the top. And I'm going to specify that my key is a string and my value is going to be a person. Okay? Nothing too like mind-blowing right now. Everyone pretty much gets it. Map is the interface. So I'm just going to call this my person map equals new. And I have all of these options in front of me. I could do hash map. I could do linked hash map. Guess what a linked hash map is? In principle, it's the same thing as a linked list. All of the objects are linked in different places in memory. Okay? So I'm just going to add a hash map and call it a day. Now, if I want to add a person to this list, I would say add a person to this map. I'd say person map dot put. And at this point, I have to supply the key and the value. So my key for person 1 is going to be M. And my value is going to be Michael. For person map 2, I'm going to make my key BR. And my object, since I didn't create one, I'll have to copy this. Okay? There we go. And for the third one, person map dot put, and I'll use a key of J. All right, nothing too mind-blowing. I think everyone recognizes what we're doing here, right? Okay, so I have my map. Here's the thing, I can't use a for each loop on a map. It's not possible. Because map in itself, if we look at it, we go up to the top, map is the top. It doesn't extend from iterable or from list or collection. Map is a separate thing. So you may be asking, well, how in the world do I iterate through a map? Well, map does have a value that we can get. We can get a key set. And if we think about what a key set is person keys. Key set is a collection of keys from the map. So what would those keys be? Anyone like to take a guess? Yeah. M, BR, and J. Those are the keys. So I'm going to be able to get a key set. But what in the world is a set? Well, if we go to set, we can see set extends from, collections. So I can do something with collections because the for each will actually work with a collection. So I can say, okay, I have a string, because that's what the key is. And I'm going to say this is my key, and my collection type is person keys. So what do I do with that now? I can obviously iterate through, my key, and what would that give me? Well, let's do it. It gives me the keys. But remember, quit. There we go. Stop doing that. Let's just do that. Okay. So remember, if I have the key, what can I do with the key? I can get something, right? So I'm going to go back to my person map, and I'm going to get the key. Huh? Yeah, yeah. So all I have to do is pass in the key. Now, this, goodness. All right, so now this I can get a person from, right? And of course, I can, again pass out my person to a system out print line. I could use it to modify that person or do whatever. All right. So if we run it again, we can see that now we have a way to access the objects in a hash map. Now the important thing though about the hash map is I don't necessarily have to throw in a key set to do this. I could just say, system out print line, person map, get m. And I'm just going to put a label here just for our own purposes. Getting something from a map. Okay? So if I run that, I am accessing directly by that key. Now the reason I'm highlighting this is think about the power of what you have. If you know the key, it doesn't matter how big that collection of map is, you can immediately grab the value right out of that map because you have the key. Okay? It's kind of a powerful notion when you're thinking about how you're going to use your objects in programming. Okay? All right, any questions so far? A common usage for a map or a hash map is what we call a state, something that will control the state of a program. So if we think back to, say, your game that you guys played, that you guys made, and let's say that I wanted to store the state at startup of different enemies, I could do that. I could have the program start up and initialize this map from data that maybe I store in a file. And now that map is available, and all I have to do is say, hey, get my enemy map, and here's the key, and immediately I've got that person, right? Or think about it in terms of an institution. If you're given a task to go through a bunch of records and sort them a certain way, but you need access to those records on the fly instead of trying to go to the database every time, you could, as the application starts up, you could say, I'm going to load up the data, and then now I can access a particular record on the fly immediately out of memory, right? With maps. Okay. Any questions so far? All right. Let me introduce another rub to this. Let's say that you now need to sort. Let's go back to our list. Right now, I have these objects, and I have Michael, I have Brian, I have John, right? But let's say I need to sort those objects in a particular way. How would I do that? Well, because we're using a record, I don't know, let's see, Java record, is it sortable? It's a comparator. Now, we're not going to get into it right away, but today, and I'm not sure your textbook is going to get into it either, but we have this object called a comparator. And there's two things. There's comparable and there's comparators. So with a comparator, you can define a particular object and say, okay, I want to create a custom ability to compare those objects. And you can do that with a comparator. With a comparable, I believe, is an interface. Yeah, here it is. It's an interface. So you could say, hey, I want my record. I don't know if I can do this or not. Let's see. Implements, comparable. I don't think you can. With a standard class, you could, but you would implement comparable, and you would specify the type that you're going to make it comparable on. And then when you use your list, you can actually do collections.sort. So there is this class called collections, and you could call sort on it, and you could sort that class or that list, anything that uses list, and it'll sort it. Okay? All right. Let's go back. I don't want to clutter your brain with too much there. Let's go back to map. And we have our map. We've looked at that, the hash map. These are different keys that you can use in your hash, different methods you could use. You can clear your map, which is actually kind of powerful if you're using it to store state and you want to reload that map with new data. Calling clear will actually empty everything out of it. You can get the key set. You can get the values. Values is the same type as key set. It'll give you a set of all of the collections, all of the values. Okay. And then we have something called a tree map. Now, a tree map is super nice. With a tree map, what it'll do is it will actually sort everything that you put into the map. Okay? So let me give you an example. Let's go back to IntelliJ, and let's change this and call it a tree map. And it has to inherit, of course, tree map. Now, automatically, you see here in this list, I have MBR. When I get the set out of this and I try to print it out, it's going to have a different direction to it. Okay, so let me comment some things out here real quick, so we can see it just for what it is. Tree map is going to order by the key value. So if I put in MBR, let's create some other things in our person map, just to make it let's put in something with A equals new person, and I'm going to say Adam, and last name is Jones, and again, I don't care about the date of birth right now. All right. The way I've set this up, because now we've changed it to tree map, it will automatically sort these values in alphabetical order for us. So if we run it, you'll notice that Adam, Brian, John, Michael, it sorted the keys automatically for us. So there's a lot of power there with that. But the downside, of course, of a tree map versus a hash map is it's more memory intensive, right? And so you have to be careful, of course, how big that tree map gets. Because what you're telling it to do when you use it is, hey, when you spit this out, make it alphabetical order, right? So it's the pros and cons. Know what you're going to use it for and why you want to use it. Just don't stick with it because that's the only thing you know. There's always a reason why they create these different types of objects in Java. Okay. Any questions so far? All right, so we have our tree map versus the hash map. Hash maps provide faster access, don't guarantee order of keys. Tree map maintains the order of keys, and it's slightly slower access. Makes sense. Okay. Then you have the set container. Now, a set is it's another collection. Set is basically just a set of things. With a set, you can't have duplicates. Okay, there's no duplicates with a set. So if I create in this class, if I tried to create a set of persons in this class, I couldn't have two Adams unless they were spelled differently. I don't know how you would spell Adam differently, but if you spelled it differently somehow, then you could have those be in there. Generally, though, sets, you can't have duplicates. That's a nice feature because, say, I want to remove dupes in a list. Lists can have duplicates. I can have multiple duplicates of certain things. If I wanted to dedupe something, I would take that list, throw it into a set, and now I've automatically removed all of the dupes. Okay? Set is the implementation. Set is the interface. Hash set is the implementation. Okay? And again, T represents the generic type, the type that we're creating it for. You have add and remove, very basic methods. You can interrogate. You can ask it, does it contain a particular item? It'll tell you if it does. It'll return true or false for that element. And again, size. It'll tell you the size of the hash set. All right, hash set versus tree set. Can anyone guess what tree set does? It orders it, right? It makes it all in order. All right, now we get to something else that's very interesting. A queue. Does anyone know what a queue is?
It's like a line where things come in order of when they begin.
Yep. That's it. It just maintains the order that they come in. And queues are kind of interesting. If you look at, I'm not going to scroll all the way back, okay, but there is no like queue class implementation, so to speak. Linked list implements queue. So if you wanted to use the queue particularly, you would do something like this. You would say, queue person, linked list. And what that would do is you would only have the methods available on persons that are associated with queue and not the linked list. You guys understand that principle? If I declare this a linked list, then I get all of the methods that linked list has. But because I declare it a queue, I only get the subset of those methods available to me because they're only implemented. Those are the only ones I'm asking for that are implemented, that implement the queue. Okay? So if we go back to our slide, though, in the programming, in the server world, they have these things called queue servers. There's one called RabbitMQ. There's one called ActiveMQ. And what these do, they allow applications to communicate across different distinct domains. And when they're communicating, think about what happens, say, when the network goes down. Well, when the network goes down and I try to send a message, across the network to another machine that's going to read it, message is lost. So what a queue does is they try to put these queues on the edge of these networks or these servers, server frameworks, right? And so we have something that communicates and sends a message to the message queue, and it just holds them there. So that when the network comes back up, so network's back up, it goes back out and it reads the message queue again. So you maintain a state, an order of messages that come in. Queues are very important in that way. Yeah. So you have add and you have remove. Typically, when you read from a queue, it automatically deletes from it. That's the way the queue works. As soon as you open it, it's gone. Okay? That's the idea behind the queue. So again, queues methods, because it is designed, it's implemented by the linked list, you have a lot of flexibility with memory with the queue. Okay? All right. You have add, remove, poll, element, and peek. Peek is the idea where you read the, you see if it's there, but it doesn't delete it. Right? It's what you all do at Christmas time when your parents are wrapping the gifts, and because if they catch you, right, then the gift is gone. It's taken away. No one's parents are like that, right? But if you peek, all right. Bad example. Anyways, queue interface, these are common implementations. You have linked list, priority queue, link blocking queue, array blocking queue. Okay. And again, these are primarily, the idea behind the queue is trying to maintain this state of objects. And so a lot of servers are dedicated just to doing queues. Then you have not the D queue, but the deck. Everyone kind of thinks it's pronounced DQ, but it's not. It's deck. This again is it provides a ordered element insertion and removal. Okay. So the deck, the linked list is one of the several types that implement the deck. I'm not going to spend too much time on this, but just be familiar with what these are. Okay. We could quite literally take probably 2 weeks to focus on all of collections, but we won't get to the fun stuff next week. Next week, you guys are going to be creating graphical applications. Yeah. And then the following week, the week right before exams, you're going to use something called Java FX. Yeah. So the idea with the graphical stuff is you now have a basis. You know all of the basic things you need in Java to create graphical objects. You understand the state and how these all work. All of these data collection types and so forth. Okay, I'm going to skip through these. I'll post the slides so you guys can read them, but I'm not going to go through them in full here. The deck implementations, linked list, array deck, link blocking deck, concurrent link deck. Okay, and that's it. All right, collections, they're powerful, okay? If you decide to go on with programming later on, and especially in a Java shop where they're using these, and your boss says, hey, I want you to program this to use, we're going to collect some data, and we're going to sort it and order it and do all these different kind of things with it, take detailed notes and begin to ask, what type of collection do I need to use that meets the criteria of what the customer is asking for? Don't just try to shove everything into an array list. Think about what is needed, okay? In fact, one of the first Java interview questions I received was about just that. And I blew it. I said array list. They're like, well, when would you use the array list? For everything. I'm like, well, what about this? I don't know about that. Right. So just pay attention to collections. It's powerful stuff. Okay, I'm going to switch real quick here, and we're going to take a look at the next 2 weeks. This week is, of course, on collections. There's about 7 assignments. We have 1 quiz on it, and you have a discussion forum this week. Okay. Next week, we're going to be getting into GUIs, Java Swing, the Swing library, and you're going to create some apps, and we're going to create some apps together. And next week on the 24th, your project 3 is due. Okay. I didn't create a video for this because honestly, this project is so basic. You guys should just be able to read the, just read the assignment and produce it on your own. It's not hard.
But not Purdue.
Huh?
Not Purdue.
You know, if you receive instructions from your boss and says, this is what I want you to code, that's the idea. Yeah. All right. So next week we're going to be doing Java Swing. I've already opened it up if you want to start getting a head start on it. And that will be all of the final graded assignments with Chapter 14. Okay? There's nothing left after that. Now, week 16 is Java FX. And this is not in your textbook, but I'm going to show you how to use it. And I think you guys will probably find it very enjoyable to play around with. After that is the final exam on May 9th. Okay? Open notes, open books. You'll get 3 tries. We'll have 2 hours to take it.
Will that be at our homes
Nope, it'll have to be here.
here?
Yeah, it'll have to be here. You will have to be here for that.
What if we cannot make it on that day?
Then you need to see Dr. Bobby and tell her that you can't make it. Okay? For the final exam, they're very adamant about you guys being here for that. Okay? Assignments. We have this week and next week. I got an email from one of the students, I can't remember who sent it to me, asking when the deadline is. Next week, the end of next week is the deadline. You have to have everything done. Everything. Okay? Can't wait until the day of the exam and say, hey, can I get an extension for a couple of days? No. You got to have everything done the end of next week. The end of next week's, right? Because we start on a Thursday, so it'll be the following Wednesday after next week.
Do we have a specific date for Saturdays?
A specific date for clarity. Well, that would be
28th?
May 1st or May 2nd. May 2nd is the date. Yeah. Everything has to be done. Okay? All right. No one's gotten behind in here, right?
No.
I have
On
a
top
question.
of it.
Yes.
What do we use Java FX for?
It's another type of GUI implementation.